Anybody need more time for this? Alright. The next proposal we have is number 17, CNC Lathe Updates for Mechanical Engineering Student Machine Shop.
Yeah, hi. My name is Vigo Hansen, and I graduated from UW last year, and I now work as staff at the Aeronautics and Astronautics Department. If you'd all please open the PowerPoint presentation that was distributed to you by Josh. I'm just going to move through the slides here. This proposal is for 2 CNC lathes to be added to the Mechanical Engineering Department Student Machine Shop. And these are special lathes. They're CNC lathes. And what a lathe does is that it cuts axisymmetric parts by rotating the part and using a little tool to scrape off material from the part, be it a metal or a graphite or polymer component. And because it's a CNC machine, that means it's under computer numeric control, so it can move and interpolate very accurate curved profiles. And a good example of that would be some of the rocket nozzles that we recently launched at a national competition where UW won the top awards. And this is from a 1,000-pound thrust rocket engine. You can come take a look at it if you like. But it uses a bell contour on the inside of the rocket nozzle, very similar to, like if you looked at a nozzle on like a Saturn V, you'd see that curved profile. This technology of CNC is essentially an industry standard now, and we're trying to gradually update the 6 manually operated lathes in the shop that were donated by Boeing about 20 years ago. We can't afford to update them all at once, so we would like to purchase 2 lathes at this time, and then gradually try and update those further in coming years. And then in the PowerPoint I included some drawings and pictures of the nozzle, and then kind of a breakdown of the cost of each item in this proposal. The base cost of each TL2 CNC lathe is $27,000. In order to fully use the equipment, they require a number of accessories, including coolant systems, tooling, and enclosures. And we believe that that's necessary to fully and safely utilize the machine, and those are $19K of accessories for each machine. And then there's another item that kind of I wanted to tack on there because it's related to the general theme of CNC equipment, which is the 4th Axis Unlock software for a piece of equipment that we purchased last year on another STF, but that's only $2,000. Okay, just a quick overview of the general metrics. As far as student access, the UW Mechanical Engineering Shop is open 8 a.m. to 8 p.m. on most days. There's a free safety course required, and it's open to every single student on campus. As a result, it's really kind of the flagship student shop for the entire school. And it's highly accessible. It's very visible and used by many different student design projects, including the sounding rocket team, which I was the team leader for, the Formula car team, human-powered submarine, and other projects in other departments. As far as departmental support and responsibility, there's specialized training courses available in ME 355 and 409, which will teach you in more depth how to use a CNC machine like this, as well as one-on-one instruction is available from 2 full-time mechanical engineering staff members that run the machine shop. They also have an existing program to cover consumables and maintenance of the equipment. As far as scholarship, I would argue that having industry standard CNC equipment is really essential, and also increases the competitiveness of student research and UW design teams like the rocket program, and that increases the recognition of the school. As far as cost benefit, the total cost of the proposal, including everything, is $100,000. But I believe this is justified because we only have 1 CNC lathe available right now for students, and that machine is pretty much in use every day. It recently broke because the motherboard failed, and it was out of commission for about 2 weeks, and that put us in a really bad position. I also want to point out that our supplier, Selway Machine Tool, is giving us a $15,000 educational discount on the purchase, and that the replacement of the current manual lathes is sorely needed. It's also important to recognize that with this type of heavy machinery, if it's properly maintained, it could last for 10 to 20 years, as the current lathes were donated in the 80s by Boeing. Now I've included a couple of backup slides at the end of the presentation with YouTube videos and other information, including a video of firing this rocket that these nozzles are from. So I'm ready for questions.
Any questions for that?
Yeah.
What are your plans for your old manual lathes?
Those would probably be given as hand-me-downs to other departments that may, not have very advanced equipment, or they would be auctioned through UW surplus.
Yeah, just to kind of clarify, so there's like two of everything except for the fourth axis drive. Can you talk a little bit? You said that's for the proposal from last year?
Okay, yeah. I did 2 proposals last year. Everything went fine, except for there was some miscommunication as to what features and capabilities was in a machine in ME that we were trying to upgrade. All the original invoices had said that it was fully equipped for fourth axis. However, somehow something slipped by and I didn't verify the information that I was given, and that the software unlock code had never been purchased. So we have all the equipment, we have all the hardware to use our fourth axis that we got, and I mentioned this in the annual report that I filed, but we just don't have the software unlock serial number from Haas, which they're refusing to give to us unless we pay them $2,000.
Okay.
And I mean, that's something we're going to really make an effort to avoid in the future, but it's with like a complex, multifaceted system like that, that can happen.
Sure. Yeah.
What's the radius capacity of these?
Oh, well, it's I believe a 10-inch chuck, and the total swing between the center and the bed is like 18 or 24 inches, and then the length of the lathe, as far as accessible space, is around 5 feet. There's a YouTube video in there that shows a guy walking around next to it. That's pretty useful for the size scale.
Thank you.
Yeah.
Any other questions for the author? All right, thank you.
I think the next proposal might be mine too, if you haven't wondered.